Right, so inverses. If you have a relation, okay, you find the inverse by exchanging x and y values, okay? Literally just swap. So now, once you swap x's and y's, everything having to do with the x's gets switched over to everything having to do with the y's. So for example, you know how domain is everything having to do with the x's, right? And range is everything having to do with the y's. When we switch x and y, the domain and range also switch. So if you have domain and range for a function, it becomes range and domain for another one, okay, for the inverse. Okay, so take a look here. I know there are brackets here. So this is a relation. First, we want to find the inverse of this relation. Okay, so with each coordinate point, you know how this is 1, 3? You literally swap it and it becomes 3, 1. The next one becomes 6, 3. I'm sorry, 3, 6. You know what? I'm going to do this in a different color. So this becomes 3, 1, 3, 6. What's the other one going to turn into? And then 0, 1. Okay. Now, okay, so that's definitely the inverse. Now, let's graph the original and the inverse over here. And that red line over here, it's not an accident. It's there for a reason. So let's do the first points. 1, 3, and 3, 1. So this is 1, 3. And then it's corresponding one, right? 3, 1. Okay. Do you see how those two are symmetric, same distance around that red line? Okay, now let's do the second point. 6, 3 and 3, 6. Okay, whoops, that should have been in blue. Do you see how those are symmetric around the same line, right? And then let's do 0, 6 and 6, 0. Okay, look, those two, each pair of points is symmetric around that red line. You see that? So let's do the other one. What's the other one? 1, 0 and 0, 1. Okay, that too, right? So that's a big deal with inverses. Whatever the function is, the inverse is like the mirrored image around that line, okay? This line, this is a special line. The equation for that line is y equals x, right? Slope of 1. So that's what inverses do, okay? So that dotted line represents the reflection of the function and its inverse. It's the mirror between the function and the inverse. Okay, now let's talk about domain. For the original function here, the domain is all of the x values. So I have a 1, a 6, a 0, right? If I write it in order, the x values for the original are 0, 1, and 6, right? What is the range of that original function? I have some 3's, I have a 6, I have a 0. So 0, 3, 6. No. Okay, now let's do the domain of the inverse. The domain of the inverse is, let's see, 3, 6, 0. Oh, it's 0, 3, 6. They're just flipped, right? And the domain, the range of the inverse, 1, 6, 0, so 0, 1, 6. So do you see how the domain and range get swapped between the function and the inverse? Okay? All right. Now, so now that we know what a function's and what an inverse looks like, how do we find an inverse? Okay? So first of all, if you have a function f of x The symbol for the inverse is f to the minus 1 of x. F inverse of x. Okay? That's how we write f inverse of x. Okay, so how do we do this? First, change f of x to y. So instead of f of x, just write it as y. Next, this is the key step. Exchange x and y. Solve for y, and then replace with f inverse. Okay, let's just do it. So here I have f of x equals blah, blah, blah. All right? First, rewrite it. Another name for f of x is y, right? So just write it simply as half y equals half x plus 3. No math is being done in this first step. Okay, now you have to exchange the x and the y. So this is x equals half y plus 3. Again, little to no math is done in this step. Just swap x and y. Now I need to solve for y. I need to get y alone. So what I do is I subtract 3. So I get x minus 3 equals half y. And then multiply both sides by 2. So 2x minus 6 is equal to y. But the last step is rewrite it. So f inverse of x is equal to 2x minus 6. Once you find the inverse, you can't leave it as y. It has to be f inverse of x. Okay, so now let's graph these. Let's graph the first one, half x plus 3. Do you remember how to do that? The y-intercept is 3. And then the slope is 1. I go up 1 over 2. Okay? And I'm actually going to put up a couple more to do a straight line here. Okay? What second number? This? Yeah. So the slope is half, right? So that means you go up 1 over 2. Okay, now let's graph the inverse. 2x minus 6. So I'm going to go down 6, down to minus 6, then up 2 over 1. I'm just going to put some more points. Okay? Do you see how the two of them, again, are mirror images of each other around that line? Right? So anytime you find an inverse, that's how it's going to look. It's going to be mirrored around that line. All right? Okay, let's do another one. So first, rewrite it as y equals x squared plus 3. Now what do we do? X equals y squared. So x equals y squared plus 3. Now I need to solve for y. So what do? Right? Subtract 3. Okay, x minus 3 equals y squared. Now, take a square root, take a square root. So I get y equals plus or minus root x minus 3. Okay? So that means the inverse is f inverse of x is plus or minus root x minus 3. Okay? Now, let's graph these. The first one, x squared plus 3. What kind of a graph does that give me? It's a parabola. It's moved up 3, right? So we go up 1 over 1 like this, over 2, up 4, here. Okay, so this is what this parabola looks like. Huh? So here, this one, we're graphing this one. It's x squared plus 3. That plus 3 moves it up. And then you go to the right 1, up 1. And then if you go to the right 2, you go up square of 2, 4. Okay? Or you can plug points in.
Why do you go 2 though?
Okay, so let's, so this is x equals 2, right? So plug in 2 here, you get 4 plus 3, 7. So it would go to 7. Okay? All right. Now we're going to graph this. Now this is going to be a little bit more, it's a little bit more fun. So take a look at this. I have f of x equals plus or minus. That plus or minus means there are actually 2 functions. The first one is positive root x plus minus 3. The next one is negative root x minus 3, right? So plus or minus root x minus 3 actually means there is a plus version and a negative version. So we technically have 2 square root graphs to graph here. Let's graph this first one. If it's root x minus 3, it's moved to the right 3 units, 1, 2, 3. And now if I plug in a 4, this is going to be, square root of 1, which is 1. So that looks like this. Now I want to pick the negative one. So again, it's moved to the right 3 here. Okay, let's pick a point. Let's put in a 4. It's negative the square root of 4 minus 3, negative 1. So that goes here. So what essentially we're doing is what you did on the homework last night. We're just doing it twice in one graph. So now that looks like this. It's a sideways parabola. But now look at the purple one and the blue one. Do you see how, again, they're mirror images of each other? Right? Do you see how these two are mirror images of each other? So it's an inverse. So that's how we know it's an inverse. The inverse also, like, if it's rotated around this, it's like taking this and kind of rotating 90 degrees over this way. Okay? All right, now, questions?
Yeah, can you explain how you got the negative reflection portion?
So imagine you're graphing this. So it's moved right 3. So we start here. Huh?
It's 3 coming 0 for the first one.
Okay. So now plug in a 4.
And then you get square root of 1.
Negative.
1 times
Negative.
Yeah. And then when you get negative 1, then what do you do?
So if it's 4, you have this, right? Okay, so here is the initial end point. Now I'm going to plug in another point. Remember how you were doing it in the homework? You just go over one and like plug in the next one, right? Plug in a point here. How did we learn to graph yesterday? We were plugging in points, remember? In here, right? You guys remember that? Like this was this was the initial end point, and then we plugged in a 2, right? And then we plugged in, you guys see that? Okay. Okay, so that's about inverses. Okay, now, look at this blue line here, okay? I'm going to actually highlight it. Okay, look at this. Is that a function? Does it pass the vertical line test? Yes, it's a function. Okay, now, take a look at this. This does not pass the vertical line test. This is not a function, okay? That means here we had this parabola, cute little function, but its inverse is not a function, okay? Because it does not pass the vertical line test. Now, it turns out if I have the original function, I can actually figure out if its inverse is going to be a function. You know how? Look at this original parabola. I can do a horizontal line test. So let's do a horizontal line test. Let's draw a horizontal line. Does this pass the horizontal line test? It fails because the horizontal line crosses the graph more than once. If it fails the horizontal line test, it means its inverse will not be a function. Okay? All right. So More about that in a little bit. So take a look here. Verifying inverses. This is why we learned the f of g of x business. How do you verify if two functions are inverses of each other? Well, if two functions are inverses, then if you do f of g of x, you have to end up with an x. And then if you do g of f of x, you have to end up with an x. Okay, so now you're like, okay, Mrs. Molly, can you literally just stop making sense? Well, let's see what I'm talking about. Okay, I have these two. So I'm like, are these two inverses? So here's what you do. You divide your workspace into two. In the first one, you're going to do f of g of x. So let's do that. The outer function is f of x. Let me just copy that down. So all these x's are going to be replaced by g of x. So this is going to be 3 times, what's g of x? 1 over 3x minus 3 in parentheses, people, plus 9. Okay, let's distribute. 3 times 1/3 is 1. 1x minus 9 plus 9. What does that equal? X. Okay, that's what we wanted. So f of g of x is x. Now, here, we're going to find g of f of x. So let's see, the outside function is this. So x gets replaced by f of x. So this is going to be 1 over 3. What's f of x?
3x plus 9.
Minus 3. Okay, let's distribute the 1/3. 1/3 times 3, that's just x. 1/3 times 9,
Why did you put in 3x?
that's a 3
Then why did we put, oh, so we put in 3x.
plus 9.
Because that's on the left.
Right, that's f of x. Okay, so now look. That gives you a 3 plus 3 minus 3. So what's g of f of x? X. Oh my God, that's magic. I did f of g of x, I got x. G of f of x, I got x. That means both of these are inverses. That's amazing. Okay, yes, question.
Can you explain, sorry, from the right part, like you highlighted the x's, like how, like now do you plug in that x to that?
No.
How does,
You want to find g of f of x. So the x here is going to turn into f of x. You're going to replace the x with f of x. So here, this x gets replaced by f of x, 3x plus 9. Okay, so let's do another one. Again, split it up and f of g of x. So f of x is 2x plus 5. Okay, again, this x is going to be replaced by g of x. So here I have 2 times, what's g of x? Plus 5. Distribute. I get 2 times half x is x plus 2 plus 5. What does that give you? X plus 7. Is that x? That's not x, so it fails. You stop. It has to be x. It's an all or nothing deal. You stop and you say not inverses.
It doesn't work on one side, doesn't work on the other.
Absolutely. It's an all or nothing deal. That's why if you get x for the first one, you still have to keep going because, like I said, all or nothing. They both have to be x's or that's it. Now, suppose you do the first one and you get 7. You do the second one and you get 7. Are they inverses? No, because 7 is not x. It's got to be x. It's very specific.
we have to cancel each other out.
It has to be x, 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 x.
Even if it's like 7.
Even if it's x. And guess where that x comes from? Because initially, when we did that whole symmetry thing, remember how this is the line y equals x? It's all about the x. Okay, so use the horizontal line test to determine whether the inverse of each function is also a function. What happened there? Okay, so determine if the inverse is a function. This means, does it pass horizontal line test?
So if it passes,
That means its inverse is a function. Okay, so go ahead and take out your calculators. Let's graph these two.
can you just write like it is or isn't?
Yeah. Okay. All right. Let me see. Where is it? Okay, so when you graph the first one, what is the first one? X cubed minus what? X cubed. Oh. Okay, so look. Go here. X cubed minus 4. So what we're looking for here is, does this pass the horizontal line test? It actually does. Okay, I know you guys think over here there's a little flat area. There actually isn't a flat area over there. That is like slowly but surely like sloping upwards. There are several ways you can tell. There are several ways you can tell. One is the following. If you trace, right? If you trace that point, you see that it's never like, the y value is always increasing. It's never constant. Okay? Another way is, if you do Control T, you also see like the y value is never constant. Another way, if you happen to zoom in, so menu, analyze, Windows zoom, if you zoom in here, right? Right? And if you like keep tracing here, it'll go up. There are not very many functions. There isn't any function that I can think of that has a flat line like that, a horizontal flat line. Okay, so this does pass the horizontal line test. So yes, it has an inverse function. No, because the question usually will ask, does it have an inverse function? I'm just writing it so when you guys write yes in your notes, you know what that yes meant. Okay, Amanda, go. Meanwhile, graph the next one. Oh, on your calculator. Okay, I'll come around in a second then. Sunny, what is your question?
So would you ever give something like this for test where it actually would be no or no?
Yes.
Oh, even the same one. Like
so it wouldn't be a function that like it would be, let's say, a parabola or a circle.
You wouldn't give us like a trick one.
No.
But that one was like.
That one, no. Those, no. There is no about it. It's like that does not pass. Okay. Anytime you see a function like that, you know that it's not a trick. It's a yes. It always keeps sloping up. A function like that doesn't exist. A function that doesn't pass the horizontal line test would look like a parabola, or it would be like a circle, or it would be, something like that. So it'd be like obvious. Okay, what about that one? Does it have an inverse? Does it pass?
Yes, it has it.
Yes. Okay. Fabulous. Okay. All right. Awesome. So that's 6.